So when you're designing a bolted joint, you need to make sure that both of these safety factors, or all of these preferably, are greater than 1, right? If you're concerned, let's consider mostly this one. These are two separate approaches. They don't both have to be greater than 1. You kind of decide what your tolerance is on what you think you know well. If you know the preload really well, if you assume you know that pretty certainly, then there's no sense in applying that safety factor on both the preload and the applied load. But if you don't know the applied load very well, and that's the only thing you don't really know well, then your load factor is the one that's important. However, you also have to consider that the joint can't gap, because if the joint does gap, this model kind of goes out the window. This is no longer valid, actually, because the force in the bolt is higher. It's whatever the preload was, plus you start, well, it starts all of the applied load gets added to the bolt. It's not just a fraction of it. All of the applied load gets added to the bolt. So you need to make sure that the joint doesn't gap. You also don't want the two pieces to come apart. That's the whole point. You're trying to keep these two pieces of material together. Well, if you start gapping, if this is less than 1, then these two pieces are going to separate. If you're relying on friction between them to prevent sliding from happening, well then it starts to slide, and that's bad too. Okay, so we need to keep both of these safety factors greater than 1. But you see, we've got kind of a conflicting relationship. If what we've got control over, of course we can choose the bolt, we can choose the the bolt size, the material it's made out of, but something else you have control over is the preload. And so let's try to figure out what is the optimal preload to get both of these safety factors as high as possible. And you realize that there's actually a conflicting relationship here. If you want to maximize both of these, the higher your preload, the greater this safety factor is. The higher the preload, the lower this top term is, the lower that this safety factor is. Okay? So they're conflicting. By increasing the preload, you go up on one and you go down on the other. So the best that you can do is to get them, since they're going in opposite directions as I'm increasing the preload, they're going in opposite directions. The best that I can do is to have them equal to each other. That's how you maximize both of them. Otherwise, one is going to be lower and the other is going to be higher. And there's no point in making one of the safety factors higher than another. So we want the two safety factors to equal each other. So we're going to try to find the preload that's best so that the gapping safety factor is equal to the load factor. All right, so to do that, we can just solve. We put SPAT minus FI. We're solving for FI times CF. That has to equal FI over F times 1 minus C. All right, FI is over here. So let's go ahead and multiply both the right side by CF and the left side, both sides by CF. We're also going to multiply both sides by F times 1 minus C. Okay, so basically I'm going to multiply this side by CF and this side by CF. That's going to take that away. And then I'm going to multiply this side by F times 1 minus C. I'm going to multiply this times F times 1 minus C. So what we can do to start off, now that we've got it in this form, is we can get rid of the f's on both sides. Those kind of cancel out, right? Okay, so let's get rid of those. And let's figure out let's expand this here. We've got SPAT minus FI minus CSPAT minus or plus CFI is equal to, I'll say CFI on the right, FIC, same thing. These things cancel each other out. We've got then FI, we can pull that over to the right-hand side or flip everything. Let's just go ahead. We've got 1 minus C times SPAT is equal to Fi, where this is the proof strength of the bolt. We want the preload to equal 1 minus C times the proof strength of the bolt. and that will cause these two factors to be equal to each other, and it's going to maximize both of them at the same time, or maximize the minimum of the two. So what safety factor do we get in that case? Well, we can just plug this into the formulas here. We can confirm that they're going to be equal, so let's plug it into this one. This one's a little bit simpler. So we've got N naught is equal to Fi, so that's going to be 1 minus C times SPAT, the proof strength of the bolt. Right? That's what the preload is, over F times 1 minus C. And so it turns out that the preload that's going to, or the value it's going to give you is, these things cancel out. We've got SPAT, so the proof strength of the bolt divided by the applied load, which is actually a really intuitive thing. You can find out the maximum factor of safety you can get. This one is equal to that one in this case, and they are equal to the proof strength of the bolt over the applied load, which makes a lot of sense. Now that is the maximum factor of safety that you could get even if you didn't preload. So it turns out that by choosing your preload exactly right, you'll neither gap nor will you overload the bolt, and it turns out preload is not hurting the load carrying capacity of the bolt at all. You think, oh, I tighten it and then it's got to take some additional load. Well, it turns out your factor of safety is just the same. It didn't matter that you preloaded or not in terms of factor of safety that you have. You get exactly the same factor of safety as if you didn't preload the bolt, but you get all the benefits of preload. These two pieces are not going to gap. Those two pieces are going to be able to hold friction. You're going to get reduced amplitude stresses. And so preload is just a good thing.